Today we're going to be doing aldehydes and ketones. So this first one is aldehydes, and if you notice on the aldehydes on table R, it shows you a C with a double bonded O and an H and then an R on the end. Now ketones are different, they have an R on each side, and the difference between that really tells you that aldehydes have to be at the end of the chain because there's an H here. That means there's only room for one more carbon, which is the R, whereas in a ketone there's an R and then like an R prime, which basically says there can be a chain on this side and a chain on that side, or I should say there has to be. So the difference between the aldehyde and the ketone is really simple. In an aldehyde, the double bonded O has to be at the end of a chain. That's what this is telling me. And in a ketone, the double bonded O has to be at some point in the middle of a chain. It can never be at the end, but it can be anywhere in the middle. All right, so our first practice problems, I'm going to do the harder one here. It's going to have to be uncondensed, even though it's not really hard. So we do CH3, CH2, then we get a C, and we have a branch of CH2, CH3, and then a second branch of CH2, CH3. Then we get another C, double bonded O, and then there's the H. I'll write this H out even though I don't have to. That's this H right here that's written out. Okay, so there is my uncondensed aldehyde. Now I'm going to number it. Normally you wouldn't number an aldehyde, and the reason being is because the aldehyde is always at the end. But now that we have branches, we have to number it, because now in the name I'm going to need to say where these two ethyl branches are. So first we name the aldehyde. It would be butane if it were just 4 carbons in a row. But for the aldehyde, and I get this off table R, I drop the E, I add Al, so butanal. It doesn't need a number because aldehydes always have to be at the end of the chain, so that's never going to get a number. No aldehyde ever has one. But the 2 methyl branches do need numbers, so this is going to be 2, 2 diethyl, even though I realize I think I just called them a methyl, diethyl butanal. So that's the full name. So the naming on this isn't that hard. We're just taking a little bit of our hydrocarbon naming scheme and kind of incorporating it into our table R naming scheme, and they're really the same thing. So you should be able to use them together. But that's it. And the only reason I numbered this was because it has branches on it that needed a number. I did not number it because it was an aldehyde, because aldehydes are always at the end. They don't normally or traditionally need numbers. That's why if you look up here, pentanal and propanal, they don't have numbers because I know where that double bonded O is. It's at the end of the line. So that's aldehydes. Now let's do ketones. So ketones are basically the same thing, except as you can see here, there's an R and an R, and what that implies is that the double bonded O has to be in the middle somewhere. It doesn't have to be the dead center, but it has to be somewhere along the middle. It can't be on the ends. So let's do this one and uncondense it. So it looks like this. Carbon with 3 H's, and then another carbon with 2, a carbon with a single H, and then it has a CH2, CH3, up or down doesn't make a difference, then a carbon with a double bonded O, then another CH3. So there is our ketone. Now I could have drawn the ethyl branch up or down, and then I would have swapped it with the H. It doesn't make a difference. Same thing with the double bonded O, although you always seen it drawn up. It could be drawn down. It wouldn't be wrong because it is free to rotate. And so that's our ketone. Now let's number it. Since the way we number it when we have to choose, and this is the case here, we have to start numbering on the right side. And the reason is simple. It'll give us the lowest possible numbers, meaning if I make this carbon 1, then the double bonded O is on carbon 2, and the methyl or the ethyl branch is on carbon 3. If I did it the other way, the ethyl branch would be on carbon 3, but then the double bonded O would be on carbon 4. And a lot of times what they'll do is if you number it both ways, you pretty much look at the sum of the numbers that you use for the name, and whichever one has the lower set of numbers is typically the one you go with. That's another way of doing it, although I don't think I've ever told you that. So here we have our 5 carbons in a row. So it would be called pentane, right? If it were just 5 carbons in a row, it didn't have a branch and it didn't have a double bonded O. Now, table R tells me I take off the E and add one. I'm also going to have to number the double bonded O because the double bonded O could be on carbon 2, it could be on carbon 3, and it could be on carbon 4. It has multiple options, so therefore I've got to know which one it is. So I'm going to call this 2-pentanone. Then on carbon 3, there's an ethyl group, so 3-ethyl 2-pentanone. And that is the formal name on this guy. Any questions there? Hopefully not. The next ones we're going to do, we should be finishing this up quick. We'll get to the harder ones. Esters are typically the hardest of the group, but we'll save them for last.